Welcome! I am Teacher M. This tutorial video is focused on finding the derivative of a linear function using definition of derivative. If you're interested, stay and watch the entire video. To understand better this topic, I highly recommend to learn first the definition of derivative. You may watch the said topic using the link on the description below. How to use the limit definition to find the derivative of a function. In this video, our focus is on linear function. To demonstrate, let's use this function as an example. Find the derivative of f of x is equal to the difference of 2x and 1. It is not required to use limit definition when finding the derivative of a linear function. Remember that the derivative of a function is the slope of the function. Since this is linear function, you can actually get the slope using its slope-intercept form. The function can be written as y is equal to the difference of 2x and 1. Take note that the slope-intercept form is y is equal to mx plus b, where m is the slope of the line. Therefore, the slope of the function is 2. Let's see if we can get the same slope using the definition of derivative. Derivative of the function is equal to the limit of f of x plus delta x minus f of x over delta x as delta x approaches 0. There are multiple options to use this definition. For this video, personally, I prefer to solve it separately. To explain it, find f of x and f of x plus delta x separately. First, what is f of x? F of x is the given function itself, which is the difference of 2x and 1. Next, what is f of x plus delta x? Substitute the x plus delta x to the given function. F of x plus delta x is equal to the product of 2 and x plus delta x. Subtracted it to 1. Distribute 2 to each term of x plus delta x. It is expanded to 2x plus 2 delta x and subtracted it to 1. This is now the f of x plus delta x. Going back to the definition of derivative, substitute the f of x plus delta x and f of x. The derivative is equal to the limit of f of x plus delta x, which is 2x plus 2 delta x minus 1. Subtracted it to f of x, which is 2x minus 1, all over delta x as delta x approaches 0. Remove grouping symbols in numerator. We have now the limit of 2x plus 2 delta x minus 1. Distribute the negative sign. And we have negative 2 and plus 1 all over delta x as delta x approaches 0. Combine similar terms. 2x minus 2x is 0 and negative 1 plus 1 is 0. Then, limit of the remaining term, which is 2 delta x over delta x as delta x approaches 0. Simplify, divide delta x by delta x, which is 1, and multiply it to 2. Then, the limit of 2 as delta x approaches 0 is 2. Therefore, the derivative of f of x is equal to the difference of 2x and 1 is 2. Or, the slope of the function is 2. As you can see, we can solve the slope of a line using this derivative definition. Another example, find the derivative of g of x is equal to the difference of 3 and x. Similar to the first example, the function can be written as y is equal to 3 minus x. Thus, the slope of a function is negative 1. The derivative of g of x is equal to the limit of g of x plus delta x minus g of x all over delta x as delta x approaches 0. Like what we did in the previous example, find g of x and g of x plus delta x separately. In this example, g of x is 3 minus x. G of x plus delta x is 3 subtracted 2 the entire x plus delta x. Remove grouping symbols. Distribute negative sign to each term of x plus delta x. And it is equal to 3 minus x and minus delta x. Substitute g of x plus delta x and g of x. Limit of g of x plus delta x, which is 3 minus x minus delta x, minus g of x, which is 3 minus x, all over delta x as delta x approaches 0. Remove grouping symbols. We have limit of 3 minus x minus delta x. Then distribute negative sign to each term of 3 minus x, which is negative 3 and plus x all over delta x as delta x approaches 0. Combine similar terms. 3 minus 3 is 0. And negative x plus x is also 0. Continue. Limit of negative delta x over delta x as delta x approaches 0. Simplify it further, which is negative 1. Limit of negative 1 as delta x approaches 0. Then, the derivative of the function is negative 1. Last example. What is the derivative of h of x is equal to the sum of 4x plus 3? Pause this video and try to find the derivative of the function. And check afterwards if your solution is correct. The function is also equivalent to y is equal to 4x plus 3. Thus, the slope of the function is 4. Let's find its derivative. H prime of x is equal to the limit of h of x plus delta x minus h of x all over delta x as delta x approaches 0. Find h of x and h of x plus delta x. H of x is equal to the function itself, which is 4x plus 3. H of x plus delta x is equal to the product of 4 and x plus delta x added to 3. Distribute 4 to each term of x plus delta x. And it is equal to 4x plus 4 delta x added to 3. Substitute h to the definition of derivative. It is equal to the limit of h of x plus delta x, which is 4x plus 4 delta x plus 3, minus h of x, which is 4x plus 3 all over delta x as delta x approaches 0. Remove grouping symbols. We have limit of 4x plus 4 delta x plus 3. Distribute negative sign to each term of 4x minus 3. Distribute negative sign. We have negative 4x and negative 3 all over delta x as delta x approaches 0. Combine similar terms. 4x minus 4x is 0 and 3 minus 3 is 0. The remaining term will be 4 delta x. Limit of 4 delta x over delta x as delta x approaches 0. Simplify. It is equal to the limit of 4 as delta x approaches 0. Get the limit? Then the derivative of the function is 4. There you have it. How to find the derivative of a linear function. Next videos discuss how to find the derivative of other functions. If you learn on this video, don't forget to hit the like button and subscribe to be updated and notified for other math lessons. See you!